So u is 2x plus 1. What is du? Two dx, yes. And the key here is to not forget about this dx piece. Now, I'm going to do this, but don't tell anyone I did it, okay? I'm going to pretend for a second that I'm allowed to do this, okay? I'm going to do d dx of both sides. d dx is my operator that says take the derivative, right? And so on the left, you see I get du dx, which is the same as u prime, right? But I'm going to keep it as du dx. And on the other side, I get 2. Now, you can kind of see that I do what to get here? Cross multiply, but this du dx is separable. So I really can think of it that way, but that's not actually what's happening. What I'm doing on both sides, right? What I'm doing on both sides is kind of saying, just take the derivative of what's there with respect to what's there. So on the left side, I get the du, right? And on the right side, I have to take into account that I want this differential. I want to be talking about what did I take the derivative of with respect to what variable. I see it on the left. I took the derivative of u. But on the right, I don't see that I took the derivative with respect to x. So we're really, right, we're taking that derivative here, but need to put on that piece that says what was our variable of with respect to which variable. Okay, I know it's a nice smooth way of saying it, but so you got to be thinking of that dx piece. If you're a math major, I'd ask you to read the section in chapter 4 about differentials. It's kind of interesting. Like if I thought about y equals 2x plus 1, right? Graph that particular piece, 2x plus 1. So that's it right there, that line, okay? Almost. But if you see here, right? Here I'd have dy equals 2 dx, right? If I look at the change in y, so I'll talk about a change in y here, right? So if I look at the change in y, I'm going to grab the piece of the function, right, and then come down here and then outline that piece. So when I'm taking a delta y there, right? So I'm picking that height. Let's make it red, right? I want to go over to the function to the right and over to the function to the left and kind of trace that area down onto my x-axis. Yes, you with me? Look at the width of the y, delta y, compared to the width of the delta x. Do you see it? Do you see it? Look at that space I mapped out on the x-axis and the space I mapped out on the y-axis. Do you see that it's twice? So that's what a differential is. It's telling me if I take some value delta x, right, and then map it up to my curve, the place where it hits the curve, right, it's going to map over to the y-axis. That's my delta y. So I'm really doing this. I'm really doing this y2 minus y1 equals x2 minus x1. And those are deltas, right? Yes, you with me? But when I take my derivative, when I go infinitely small, like a limit, what does the delta y become, right? It becomes dx, dy dx, that type of thing. So that's what's really happening here, okay? But it's enough for you to kind of cheat that you're cross multiplying. It's enough of a thought that's okay to have, even though it's not what's really happening. Okay. Anyway, I'll shut up. What do I get now? I got my u, correct? So now I'm doing the integral from 0 to 4 of 1 over the square root of u. Oh, but I need 2 dx, right? I need 2 dx. So what I'm going to do is I'm going to multiply here by 2 and multiply by 1/2 as well. Right? Because I multiplied by 1. Right? I needed the 2, so put the 2 in by multiplying, but make sure you cancel it as well. So now I have 1/2. What does this 2 dx become? My du, right? Okay, yes. So now I have 1/2 of the integral from 0 to 4 of u to the minus 1/2 du. So power rule. So I'm back to step 2, level 2, right? Or process 2, power rule. So how do I get that? So what do I get? I get u to the minus 1/2, add 1 to my new power, divide by my new power, right? And then evaluate at x equals 4 and x equals 0. We okay? So what do I have? 1/2 of u to the 1/2 over 1/2. So I have u to the 1/2, and u was what, 2x plus 1, is that right? To the square root of that, evaluated at 4 and evaluated at 0. Some books use that little, like that square bracket for the evaluate. Some just use a line straight down. So evaluate at 4. What is that? 2 times 4 minus plus 1. And evaluate at 0. 2 times 0 plus 1. So I get square root of 9 minus square root of 1. I get 3 minus 1, and the final answer is 2. Can we do that on our calculators, please? So in y equal, I'm putting my function. Remember, it's 1 divided by the square root, can't find it, there it is, of 2x plus 1. I want to make sure I can see a nice picture of my graph from 0 to 4, right? So Zoom standard is my goal here. So I can see from minus 10 to 10, right? You with me? You understanding that? I want to zoom in a little bit because it's hard for me to see. I'll just go zoom in and enter. There's a little bit of a nicer piece. Now notice I can't see 0 to 4 anymore, right? So watch what happens. Don't do this with me yet. Second, calculate integral from 0 to 4. It says, wait a minute, you're not showing me 0 to 4, right? It says no good, right? So that meaning I need to change my scale here. Look, I don't need to do this. As long as I had it on that original window, I don't need to do it, right? But I just want to get a better visual. I'm going to change my window from -1 to 5. Right? So now I'm going to see on my screen from -1 to 5. Yes, you with me? I have to make sure I get that 0 to 4 in there. So now I'm going to get a real nice picture of the area here. So here we go. We're ready. Second, calculate. Hit number 7 for integral. My lower limit is 0, so I hit 0 and enter. My upper limit, oh, it's not 0, was it?
It was
1, right? Sorry, I got to do the whole thing over. Second, it was? Oh, sorry. Doesn't matter. 7. Lower limit 0, enter. Upper limit 4, enter. and there's my area 2. So easy. Now, everybody okay? Now, what I wanted to do was show you that I can change my variable completely. So notice when I was doing this integral, at this point, I had everything in terms of u except for my bounds, right? So what I want to do here is change the variable completely. So I know that at x equals 0, 2x plus 1 would give me what? Would give me 1, right? So I'm going to change my integral of 1/2 of the integral from 1 to whatever, right? Of 1 over square root of u du. Okay, so what's my upper bound? I had x equals 4, right? And at there, 2x plus 1 is 9, right? So I'm going to go to the integral from 1 to 9. I got my integral, right? What was my integral? U to the 1/2, right? Right here, u to the 1/2. So at this point, I'm saying, okay, this is 1/2, of u to the 1/2 from 9 to 1, 1 to 9, right? And do you see I'm going to get 2 again? You with me? What happened though? Something happened weird. Oh, I get the same answer. It's u to the 1/2. So square root of 9 minus square root of 1, right? 3 minus 1, 2.
Can you scroll down?
Yes. So and now here's the thing about these definite integrals. It's your choice whether you want to return to x's or stay with the variable as u. Okay? So you could return to x's like I did originally, or you could change your bounds into u variables. All right, do 72 for me. And your choice. Do 72, and it's your choice if you want to do it as a change into u or a change into, keep it as x. Do number 72. Ian, we're looking at that single sheet that I have, and on the one side, number 72. And I'm going to draw it here, okay, in case you're lost. So I'm doing the integral from 0 to 1 of x times the square root of 1 minus x squared dx. Everybody okay? So of course you could do it on your calculator first, or you could do it on the paper first, right? You're going to do both, though, on the quiz and on the test, right? It's a little weird that my calculator is not quite exact. Trying to think of what I possibly did. I guess it's just the calculator is too dumb. It's the only thing I can think of. Anybody get 1/3? Question. Yeah. What? Question? Yeah, so if I let u be the inside, right? I take the derivative and I get negative 2x, right? Dx, okay? So if you notice, I have an x dx, I don't have a negative 2 dx. So what I'm doing is I'm multiplying by negative 2. So now I have negative 2x dx. But I have to cancel it by multiplying by negative 1/2. So the negative 2x dx, right, becomes my du, and everything left is square root of u, right? But I keep this 1/2 outside. I keep this negative 1/2 outside. Anybody get to there? No? Have you not practiced any of this yet? You basically, you could have jumped right into, well, hopefully you jumped right into doing things on my chapter 5 test, right? But we didn't quite finish. But today you should be able to do any of these problems. Do you want to see the change? All right. So can you look at mine now? Let's talk this through together. Don't write it down, please. You can do it over. You don't need to write it down. Copying it is not as good as doing it, okay? So here's my integral, yes? It's an interesting little curve. Looks like something like that. And of course, we're getting this area from 0 to 1. And it turns out to be 1/3. I get my calculator to show me. My calculator is giving me an error. It's a dinosaur. So I see there's a clear inside, right? I go through my list, I see there's a clear inside, so I let u be the inside. It might fail still, right? Just because I picked a method doesn't mean I picked the right method. But I know I had nothing else worked up till there. So I let u be the inside, and I got du. Does everyone agree? Thank you. I need to make du happen. I need to make the du show up. So if you see, I almost have what I need. I'm missing a negative 2x dx. I have an x dx, but I want negative 2x dx. So I just multiply by it. And then I have to make sure I cancel it, right? Remember, one of my tricks is multiply by 1, right? And that's what I'm doing, multiplying by 1. Now, on the right-hand side, or on my integral piece, I have in blue-green, I have du. And the square root of the inside is square root of u. So now I have this integral, and I'm noticing that I've changed everything to the variable u except for my bounds. I have the choice to change it for my bounds, okay? What would my bounds be? Remember, u is 1 minus x squared. So what would my integral become if I change those bounds to u? If I plug in a 0 here, what do I get for u? If I plug in a 0 here, what do I get for u? 1, right? And then if I plug in a 0 here, what do I get? Sorry, now I plug in a 1, right? I plugged in the 0, I got a 1. I plug in the 1, I got a 0. So that's the same piece, right? So I could convert everything to u or keep it as x's. Let me continue with my x's, right? So I've got my x's here. I do my integration. This is now a power rule integration. U to some power is a power rule. I add 1 to the power, divide by the new power, right? Add 1 to the power, divide by the new power, yes? I get u to the 3 halves over 3 halves. Keep, change, flip, right? My 1 half times 3 halves becomes 1/3, so there's my 1/3. And I put u back as x. What was the u sub? It was 1 minus x squared. Then I evaluate at 1, I evaluate at 0, and I get negative 1/3 times 0 plus 1/3 times 1, and I get 1/3. Everybody okay? Now, and Marco, this is on the single sheet I gave you there, number 72. If I come back over here, I can see that I can still finish this. So what was my final answer of an integral in terms of u? It's right here. Minus 1/3 u to the 3 halves, evaluated at 0, evaluated at 1. So now I'm not converting back to x's, my choice, okay? So I get minus 1/3 times 0 to the 3 halves, minus a minus 1/3, so plus 1/3, 1 to the 3 halves. And you can see this is gone, and I just get 1/3 again. My choice. When I'm doing definite integrals, I can completely convert to a change of variable, or I can come back to at the x world. Let's do 79. Same page, 79. So I'm doing the integral from 1 to 3 of e to the 3 over x squared dx. Weird looking function, right? But I got my checklist. Okay, what's the first thing? Do you recognize that as a derivative? Hell no, right? Is it a power rule? Hell no, there's an e in there, right? E to the x in there, yes? Okay, do you see a function and its derivative? Hell no. Do you see an inside? Yes, e to the x is the inside, right? It's where you put the money, right? I always like to think of e to the x as e to the placeholder, and that's my soda machine with the little place where you put the money in. Do you see it? You put the money in that spot. At least we used to, right? Now you touch your credit card or whatever. So there's an inside. As you practice, you'll get better at it. If you do this on Symbolab, and I will, you'll see Symbolab will say, let u be what? 3 over x. What's du? Quotient rule is okay. This is 3x to the minus 1. Yes, I need a dx, but I'm missing something in the denominator. When you take a derivative, you decrease your exponent by 1, right? So over x squared, yes? Look at what I got, though. I have a 1 over x squared dx. That's almost a u, right? I have almost what I need, but I'm missing a negative 3. So what do I want to do? I want to multiply by -3 and then cancel it with what? Yes, -1/3, right? Double negative is positive. 3 divided by 3 is 1. I'm multiplying by 1. Now I've got the integral, -1/3 times the integral of x equals 1 to x equals 3 of what? E to the u du. Notice that everything I have in green is du, right? And the rest is e to the u. This would be the same answer if I did it in terms of u. What would be my bounds in terms of u? Look at u. Sorry about that. When x is 1, what's u? 3. And when x is 3, what's u? 1. Now, to me, it looks a lot easier to do the right one than the left one. But it's your choice, okay? So which one do you want to do? The right one. Good answer. -1/3 of e to the u evaluated at 1, evaluated at 3, and then subtract. Oh my God, that's so quick, right? I know the antiderivative of e to the u is e to the u. Plus c, but I don't care about the c because what's going to happen when I evaluate and then subtract, the c's are going to go away, right? So I get -1/3 e to the 1 minus a -1/3 e to the 3.
Did you mean to switch the 3 and the 1?
I didn't flip the 3 into 1. The u sub did it. So I know u is 3 over x. So when x is 1, I get 3 over 1. That's 3. So I'm changing my bounds from x's to u's. Right? Sounds like I'm from Brooklyn. Hey, u's. Right? But changing my bound from x's to u's. Okay? So what do I get? Well, I can factor out a -1/3. Oh, this is an e, right? I can factor out an e, and what's left? I have 1 minus e squared, right? And there it is. Right, I could make it, I think I can make it look a little prettier. E over 3 times e squared minus 1. Let's get that decimal. E over 3 times e squared minus 1, right? So, second e divided by 3 times second e squared minus 1, enter, about 5.8, okay? You with me? Now let's do the calculator. Let's have the calculator do the integral. Please control me, please. Right? Don't tell me to go buy groceries. Tell me to go buy a roasted chicken or something. If you don't tell me something, I'm going to do whatever the hell I want. It sounds like I'm talking to my girlfriend right now, but it's me. You got to control me. Okay? So here's my function. I had e raised to the parenthesis 3 over x, correct? All divided by, right? All of that divided by x squared. Is that correct? My original problem? I know my bounds are 0, 1, right? No, sorry, 1, 3, right? So I want to make sure, I like to start with Zoom Standard and see what I got. I don't really see myself asking you anything other than something in Zoom Standard. You can definitely see at 1, I'm going to get a lot of area. I'm going to get all of this area, right? And you can see that's almost or already over 5, I think, right? So I know I'm going to get something bigger than 5. So what do I do? Second, calculate 7 for the integral from 1, enter, to 3, enter. Yes, I love it. I loved when I could walk out of a test knowing my grade. I was able to walk out of the test knowing my grade. I always had a question, all right, maybe I missed one question, maybe it's a 90. Right? But the ones that I knew I got. Okay, you got lots to practice, right? If it's a definite integral, you're checking with the calculator. If it's an indefinite integral, you're taking a derivative of your answer. We'll do a couple of those right now. So on the first page, actually, look at, for me, I wanted to do this one. On the back of the final exam review, number, where is it? Damn it. I thought it was, number 11. So this is, again, it's another book. I forgot to name the book. I'm stupid, but so it's number 11 on that other page I gave you today. The integral of ln of x quantity squared over x dx.
Is this an indefinite one?
This is indefinite. I don't see the bounds. So I don't want the area in this case. Remember, fundamental theorem of calculus says the integral gives me the area, or the integral gives me back the function from the derivative, right? One is the definite integral, one's the indefinite integral. In both cases, I'll say solve the integral. So you'll just have to recognize, do I want area or do I want the antiderivative, right?
Wait, is this one on the sheet?
It's on the back of the big packet I gave you, number 11. So do you see it? Is it really, really clear what it is? Yeah, there's an inside, right? What's inside? ln of x. What's the derivative of ln of x? 1 over x dx. Ah, we got that. Nice. I don't have to multiply by 2 and divide by 2, or multiply by 3 and divide by 3 on this one. It doesn't always happen, okay? So what does my integral become now? Good. U squared du. That's a power rule. Oh, that's easy. The answer is u cubed over 3 plus c. But what is u? ln. So ln cubed over 3 plus c. Easy. This is easy. All right, I'm going to check my answer now, okay? I'm going to check my answer. Of course, I could check my answer by graphing. I could graph this, right, with c as 0, yes? And then graph this and see if it makes sense for the first derivative test. When my function, original function, is increasing, the derivative should be positive. Right? So I can use my tool to check and see if I got my derivative right by checking to see if I have my integral right. But I think even easier and good for you for Calc 2 is that you take your answer from the integration and derive it, right? Get the derivative of it and see if you get it right. So forget the c. When I'm checking, forget the c, okay? Y equals the ln of x quantity cubed over 3, right? I want to do prime of that, right? So on the right side, I get y prime. Sorry, on the left side, I get y prime. On the right side, I have a power rule. So I get 3 times the ln of x quantity now squared times the derivative of the inside. What's the derivative of the inside? 1 over x. And I still had that 3. The 3 went for the ride, right? So the 3's cancel, and I get what I had. ln of x quantity squared over x. Done. I knew I got it right. I'm not worried about that problem anymore, right? Diego? Good? So, I mean, anything look interesting there that you want me to do? Anything on that back page or the final exam review? Anything look interesting there? I'm sorry, which one? 20? Sure. So 20, I've got the integral of secant of 2x, tangent of 2x, dx. Well, I know secant x tan x is a derivative, I know, right? That's the derivative of secant. So it should be one of the methods, but the problem is I got a messy inside, right? So I'm going to let u be 2x, and du is then 2 dx. Everyone agreed? I'm going to multiply by 2 and divide by 2. Why? Because I want to make dx happen, right? I want to make du happen. I want to make sure I have 2 dx inside of my integral. So now what do I have? I have 1/2 of the integral of secant u tan u du, and this is done because the answer is secant u, right? The derivative of secant is secant tangent, right? So look at that. I had a u inside, and then I went back to level 3, right? Or level 4, where I saw one. I know that derivative. I know the derivative of secant is secant tangent. But what is u again? It's 2x, right? When you're good enough, and you can see that you probably don't even need to use sub, but to get the 1/2, I think it's still safer just to do that. If you see a messy inside, chain rule's happening. Let's do 24. Is that okay if I move on? I've got the integral of the arctan of x over 1 plus x squared dx. You should see it right away. I see a function and its derivative, right? So u is the arctan of x, right? What's the derivative? 1 over 1 plus x squared dx. I have that. Cool. I have it. Nice. So I've got the integral of u du, or u squared over 2 plus c right? Power rule, once I get to the power rule, it's really simple. Add 1 to the power, divide by the new power. And so what do I get? I get arctan squared x over 2 plus c. And you could write it like that, or you could write it like they were writing the ln before. Arctan of x quantity squared over 2 plus c, right? You could write it like that too. It's your choice. Get on them, right? Get to work. Get some of these done this weekend, right? We're going to try and finish our process for integration, but we'll take a 7-minute break, okay? So come back at 10:05.